Hey guys, Mr. Bowman here. Today's learning objective is in white. We are learning to calculate the probability of an exact event using a binomial distribution. And I've underlined exact event because that's a specific type of question. And just to recap, that's the type of question where you're looking for an exact number of successes. Very similar to percent distribution. So that's when you're dealing with x equals 0, x equals 1, x equals 2. And today I thought I would run with a bit of context to help illustrate how to find the probability of an exact event. And you'll see a photo of a hermit crab, and in that crab you'll see its shell. And typically what happens is hermit crabs, they grow, they find a shell. Once they've outgrown that shell, they'll go find another shell. So in a given beach that have hermit crabs, you'll find some shells that have a hermit crab in, or some shells that have been abandoned because maybe they're too small and they just sit there empty. So what I thought we'll do today is we're going to consider, well, I'm at a given beach and I'm looking at these shells and I'm wondering, well, what's the probability of actually finding a hermit crab sitting within that shell when I pick it up? So for us, a success will be when we have a crab within that shell. And a failure, that will be no crab. So it's really important we always identify the success and the failure of a given context, and that helps us with our questions. So we've got success, failure. So let's say I'm at a given beach. I'm actually going to change pen color for this. We're going to use green. So let's say I'm in South America, and I'm at a given beach, and we've written South America. We'll run with South Africa now. I'm at a given beach, and that beach has tons of hermit crabs, tons and tons and tons, and there are hardly any shells. So let's say I've done maybe some scientific research, and I know the probability of a shell having a hermit crab in, let's say that's 0.75. So there are some abandoned shells, but most of the shells have a hermit crab in it. So let's say I'm walking along the beach and I pick up 3 random shells. So what that means is our number of trials is going to be 3 because I'm going to be picking up and looking in those shells on 3 occasions, hence 3 trials. And here I'm wondering, well, I've got these 3 shells. I wonder what is the probability of having 0 crabs in these 3 shells? Pretty unlikely to happen given it's most of the shells are there. But what's the probability of having no crabs? No crabs in 3 shells. That's what we're looking at. And in our case, we've defined success as the number of crabs. So no crabs would therefore be equal to x equals 0. So 0 crabs or 0 successes. And with these 3 variables, we've got p, n, and x, we'll be able to use our graphics calculator mode. Just a reminder, we're using BPD, so B stands for binomial distribution now, and the P stands for an exact point. And that's what we're looking at, and we'll be able to find, well, what's the probability of there being 0 crabs in these shells? So I'm going to put in x, which is 0, 3, which is the number of trials, and 0.75, the probability of a crab being in a specific shell. And that's going to tell me the probability is 0.0156, and I've rounded that to 4dp. So the probability of those 3 shells having no crabs, about 1.5%. So let's change up a scenario again. Let's say instead of picking up 3 shells, well, what if I pick up 2 shells? How will that change the probability? So we're now picking up shells, so 2 of them. So we've got to think of our variables. Is it going to change anything? So the probability, well, that's still 0.5 because the probability of a given shell having a crab in, that hasn't changed. Our n value has changed. We've now only got 2 trials because we're only investigating 2 shells. And we're still looking at 0 crabs, which means x will be equal to 0. And if we put that in our probability mode or our BPD mode in our graphics calculator, we should be able to find the probability of having no shells from those two. And in that case, it's now 0.625. So even though it's still small, the probability has increased quite a bit to about 6%. So 6% of the time, those shells will not have any crabs. And then maybe our last scenario, so maybe I'm at that same beach, and I've got 10 shells. So this time around, we've got 10 shells. It's the same beach, and I want to know, well, what's the probability of getting exactly five crabs in those shells? So we can use the same skills we've looked at. So our number of trials is now 10 because we've increased it to 10 shells. Our probability, it's still 0.75 because we're at the same beach. But if we change beaches, that probability may change. And our X value is now going to be 5 because we're interested in 5 crabs. That means the probability of getting exactly 5 crabs from those 10 shells, we're going to be using BPD mode again. So X is 5, the number of trials is 10, and the probability unchanged. So the probability of that is 0.0584, and I'll round that to 4dp. So again, pretty unlikely, probably not going to be getting exactly 5 crabs. So hopefully you found this short video on the exact events of a binomial distribution useful. Just to recap, when you've got a question, you need to be looking for 3 things. You need to find X from your context, number of successes. You need to find N, number of trials. And you need to have the probability of success as well. Probability of success. And with those 3 numbers, you can use the BPD mode in your graphics calculator to find the probability of that event. If you are wondering, the BPD mode, I have got a separate video on how to use that. It's in the description below. If you need to recap on how to use your calculator, please do. All right, now let's get into heaps of questions, guys.